Okay, here we go. Are you ready? I'm going to, sorry, it took a minute. Okay, guys, please, here we go. All right, so today we are going to learn about standard deviation. What did we learn about last time? Do you remember what we learned about last time? Oh, that pen is not, oh, it's thinking about it. Okay, I know it took a long time, guys, but I need you to come back to me and focus really quick. So, super quick lesson, we just got to get through it. So, last time we talked about average, okay? We also talked about median. Does that ring a bell? Okay. So, standard deviation is going to be a measurement of how far the data points are from average. A measurement of how far the data points are from average, okay? So if you take a set of data, I'm going to give you some examples. Let's say your data set is 1, 1, 1, 99, 99, 99. Just throwing something out there. Can you guys give me an idea of what you think the average of that data set is going to be? 50. Okay, next sample data set. You don't have to write these down if you don't want to. They're just for showing the point. So a data set that's all 50s, what's the average? 50. Are those two data sets the same? No, but they are the same in that both of them have an average of 50. So we need another way to talk about these two data sets so that there's a difference between them, okay? Because if they both have an average of 50 and that's the only thing I'm using to describe the data set, that's a problem because these two data sets are very, very, very different. So if I was teaching a class that had 6 students and I had 3 students score a 1 on the test and 3 students score a 99 on the test, is that a little bit different than a class where every single person scored 50 on the test? Yeah, I should be insanely worried about both classes, okay? But they're very different classes, okay? Another way we could get a data set that has an average of 50, what if we had like 49, 49, 49, 51, 51, 51? Would that also have an average of 50? Yeah, it would. So what we're going to talk about today is a measurement that kind of distinguishes between those two, or between those 3 data sets. Okay, it's called the standard deviation. Our abbreviation for standard deviation is going to be SD. So for these 3 data sets, the SD of that first data set is 49. The SD of the second data set, any guesses? 0. It's a measurement of how far the points are from average. So if all the points are average, yeah? What about this one? Good. Every single point in that data set is 1 unit away from average. Okay? So it's how far they are on average. So not total distance of all the points from average, but an average of how far they are away. So like this is 1 unit away. This is 1 unit away. This is 1 unit away. This is also 1, also 1, also 1. If I average all those 1s, that's why the SD is 1. Okay? These are all 49 units away, so the average is 49. These are all 0 units away, so the average is 0. Okay? But sometimes the data set might look a little bit different, obviously. In fact, most of the time, these are really unique data sets that I'm working with here. So if we're trying to find the distance on average from average, there's this very procedural, straightforward process that we're going to learn today. I despise the way they explain this particular concept to you in your book because they use an acronym that doesn't really make a whole lot of sense, but they use it through the whole entire year, so we get to learn it even though I don't like it. Sorry. Okay, so the acronym that we're going to use today is called the RMS, which stands for root, mean, square. So the root, mean, square, and I'm going to show you with a sample data set, I'm going to show you how we find standard deviation. This is a process that you're going to have to be good at. This is a process that we use a lot, starting today, ending when you take your final exam in May. We never really stop using this process. We'll go like maybe 2 or 3 class periods without it, and then we'll jump back in and use it again. Okay. The other thing I would like to mention at this point also is that we will be finding standard deviation enough that sometimes it's easier to use your graphing calculator to do it for you. So if you could please, please, please get your hands on a graphing calculator before next week, that would be so cool. There are still tons available to rent. So I told you there's graphing calculators available to rent. It's $20 to rent it for the entire year. You just pay your $20 to the finance office and then take your receipt to the library and she'll give you a graphing calculator you can use for the whole year. Otherwise, your options are buy one or borrow one, because chances are between your siblings, your cousins, your neighbors, somebody probably has one. There are enough classes that have used graphing calculators in the past that there's probably one out there, okay? So figure something out, please try. Finding standard deviation in your calculator is honestly a matter of typing the data points in and then pushing like a 2-button command and it's right there. It gives it to you, okay? And you'll see that this process I'm gonna show you takes a little bit. So doing it on your calculator is way, way, way faster. Okay, so the sample data set that I'm gonna use, can't remember what I decided to use. Oh yeah, let's just do, so this is our example. And we're going to find the SD, or the standard deviation, of, in our data set, we're just going to do something super simple today, 3, 9, 12, 15, 21. Okay, it doesn't tell me when I steal this list from the textbook, it doesn't tell me specifically what these numbers are, like what kind of data set this is, and that's fine. I don't really need to know in order to find the SD, but just to make our conversation a little more interesting, let's put some sort of context on those numbers. So when you see the numbers 3, 9, 12, 15, 21, any idea what they could represent? Just throw something out there. I have an idea. I guess I could just tell you what I'm thinking. Okay. What if this is the number of tardies you have this week? Is it possible? We had this question last period. Can you get 20 tardies in 1 week? You can get 20. Can you get 21? No. Yes, if you have early morning seminary. If you are habitually tardy, you can manage it. I am so proud of you. You are at 21 tardies, which means if you have early morning seminary 4 days, you were on time to 3 classes, or 3 teachers just didn't catch you sneaking in late. So good job. Proud of you. 3 seems a little more reasonable. As your mother, I probably wouldn't strangle you if you had 3 tardies this week, but 21? We'll see. Okay, don't try it, London, please. Okay, all right.
And McKenna Harris from the front office.
Sure. What? Yes.
115
Oh.
to check out.
Done. Okay. All right, so standard deviation of this data set. So basically, we are finding out how far these numbers are from average. It's gonna be a little tricky if I don't even know what the average is, okay? So another thing you're going to have to be good at in this class is looking at a data set and just getting a ballpark figure of what that average might be. So can you look at 3, 9, 12, 15, and 21 and tell me approximately, with no calculations, don't get your calculator out, just approximately what do you think that average might be? 13 and a half. What else? 12-ish? Yeah? Okay, if you said somewhere between like 11 and 14, great job. If you're thinking like 37, nope. Like dumb. Just kidding, that's rude. Okay, watch this though. Look how interesting this is. How far is 9 from 12? How far is 15? How far is 3? How far is 21? What's the average? 12. Because they are exactly the same distance, the average happens to be 12. I did not expect you to see that. Just wanted to point it out. Okay, also, now that you know that the average is 12, can you give me a ballpark for the standard deviation? Approximately how far are those numbers from 12? First number I heard was 6. It was very quiet, slightly unsure. Any other guesses? 6, 9, somewhere between 3 and 6?
Yeah.
Okay. So how far is the furthest point from 12? It's 9 units away. How far is the closest to 12? It's 0 units away because 12 is one of them. So it's got to be somewhere between 0 and 9, and it kind of depends how many numbers you end up with that are 9 units away and how many are 0 units away and how many are, 3 units away, okay? But those of you that said somewhere around 6-ish, good job. Yeah, 6-ish. I'm not saying if you didn't say 6, you're wrong. You did a good job. I love all of you. I'm so proud. Okay. All right, we proceed. So I'm going to show you the process for finding standard deviation. Again, in order to find how far they are from average, the first thing we're going to do, so step 1 is to find the average. Okay, I already told you what the average is, but we're going to calculate it anyway. 3 plus 9 plus 12 plus 15 plus 21, all divided by what? 5. I believe that makes 30, and those other 3 numbers make 30, so that's 60 divided by 5, which is 12. Shocked and shaken, the average is 12. Okay, good? Step 1, not too bad. Step 2 is the RMS piece, okay? But in order to do the RMS, we're gonna make a little table, and I'm gonna give you the table for a while, just so you get used to the process. And then at some point, I'm going to take the table away and expect you to be able to do it on your own. So the table is going to look like this. We're going to have the data, or sometimes we just call them the X's, in our first column. Okay, and you can write them in any order you want. I really don't care, but the OCD in me always makes me put them in numerical order. I can't bring myself to write them in any other order. So you get a 3, a 9, a 12, a 15, and a 21. The second column of this table is going to have a couple of different titles, just kind of depends on where we're at in the book or how we're feeling that day. Sometimes it's just called deviations, okay? But sometimes they'll put this weird looking formula in here. That says X minus X that has a bar over the top of it. Okay, X bar is average. That is the symbol that we use to represent average. So X bar equals average. Okay, so deviation. What does it mean to deviate? Go away from. So the question is, how far did 3 go away from average? Or what is x minus average? So x in this case is 3. 3 minus, what's our average again? 12. What kind of number is that? It's a -9. Does it make sense to you that the deviation for 3 is -9? So what does that negative tell us? Yeah, 9 to the left, or 9 smaller than the average, right? Because 21 is also 9 units away, but watch. X minus the average this time gives us +9. So please, 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 when you're filling out this table, please include the negatives and the positives. It's going to be important. Now, you're going to see the negatives and positives disappear in a second. So you'll be like, why is she telling us it's important? Because it is. It will be eventually. So just let them be. Okay? Okay. All right. How far is the 9 from the 12? -3. How far is 12 from 12? And 15? +3. Good? That's not hard, right? Okay, next column. I told you in a second we were going to make the negatives disappear. The title of the third column looks like this. What is that? Say what that is. Deviation squared. Okay. Let me tell you why we have to square the deviations. If you have -9, -3, 0, 3, and 9 as your distances from average, I told you that standard deviation was the average distance from average, right? So let that sink in for a second. Average distance from average. Well, if these are all the distances, why can't I just average that set right there? Because when you add them together to start getting the average, what do you get? 0. They cancel each other out, right? So you have to get rid of the negatives, because right now, if I add them together, the SD is 0. When you look at this data set, you better darn well know that the SD of that data set is not 0. You follow what I'm saying? Okay, I just realized I have not had my mask on this whole time, so I'm going to continue talking without my mask on, but I'm almost 6 feet away. Okay, sorry. I just realized I honestly would have stopped a long time ago. So anyway, okay, but now that I'm going, I'm just, you're infected if you're infected. I'm sorry, friend. Okay, anyway, I just recorded that. Okay. Whatever, you know. Now they have all this evidence against Mrs. McMurdy. You're being fired because you weren't wearing your mask. Well, how do you know I wasn't wearing my mask? Because you posted it on the internet? Oh, my bad. Okay. All right, so deviation squared. Now, those numbers are a little crazy looking. Just calm down. We'll bring it back down, okay? Just calm down. Relax, guys. It's going to be okay. All right. What have we done so far? What is this? This is how far the numbers are from average. What's this?
And then you do the deviation squared.
And then we squared them. Okay? So that's step 2 to fill out that whole thing. Step 3 now is to find the average of the squared deviations. So the average of the squared deviations. So what does that look like? 81, 9, 0, 9, 81, all divided by what? You see how I'm finding average again? It looks like 90 plus 90 divided by 5, maybe like 36. Okay, now look at me. I cannot tell you how many times I have had a student get to that point and be done. So I beg of thee, look at the data set. Do these numbers look like they are approximately 36 units from average? No, they don't. So don't tell me that the standard deviation is 36 because it's not. Foolishness, foolishness. Dumb. Okay, so fix it. How do I fix it? What did I do to make them so freaking large? I squared them. Now I undo that. Easy, right? Step 4, take the square root of the average of the squared deviations.
So this seems pretty easy, just like steps.
Yep.
Okay. I can get behind.
Square root of 36 is?
6.
How many of you thought that the SD was 6 in the first place? Wow, brilliant people, brilliant. Okay, does it make more sense to say that the average is 6? That these numbers are 12? Listen to this phrase because we use it a lot. This data set is numbers that are 12, give or take 6 either way. So people on average got 12 tardies this week, give or take 6, which means majority of people are somewhere between 6 and 18.
It's pretty good. It's like right where I want.
Zero's pretty good.
No,
Just
6 and 18, that's the sweet spot.
6 to 18 in a week?
Yeah, that sounds great.
That's more than one a day.
Yeah, but that sounds so nice.
Bless you, children. Good thing I'm not your mother. Okay, good? Any questions? Now, someone explain to me why the heck, there's that word, yep. It's recording, it's recording. I remembered, right, I stopped myself. Why in the world, my friends, is this called an RMS? Because I took a root, this is a mean, and I squared some stuff. Right? Okay, so it doesn't say anything about the deviations. And then why would you RMS when you could just SMR? I mean, I get the SMR like has its own, but back in the day when this was written, I don't think SMR was even a thing. So yeah, okay. You understand why sometimes I get sad? Okay, because the book is full of RMS. Anyway, there it is.
What would you call it? Besides SMR, what would you call it?
I don't think I would call it anything. I think I would just say it's finding the standard deviation. So I think I would call it finding the average of the deviations after you get rid of the negatives. I don't have a cute name for it, but RMS just isn't it. Just is not it. Anyway, okay. One other thing I need to teach you now that you understand that process, because of course you understand it perfectly. We've done it once, okay? So the other thing I need to teach you is what's called, oh shoot. Yep. It has a name, but your book never uses the name. Oh, the empirical rule. There it is. See, I knew it would come eventually. There's this little thing called the empirical rule. Really, you don't need to know that it's called that. Really, you need to memorize 3 numbers. Ready? 68%, 95%, and 99.7%. Those are 3 numbers you need to know. Why, you ask? I will tell you. 68%, okay, if you have a data set that's not, it doesn't have major problems, basically. If you have a decent sized data set that doesn't have major problems, then 68% of your data will be within 1 standard deviation of average. Okay, so 68% of the data is within 1 SD of average. I'll show you an example of what this looks like some more in just a second. So 68% of the data is going to be within one SD. 95% of the data, what's your guess? Will be within two SDs. Oh, wow. Why does my D look like that? Whatever. 99.7 is basically what? That's basically 100%. Okay. So if you are in a situation where you are finding that a lot of your data is outside of 3 standard deviations, something's wrong. Okay. What would you say about someone whose height is 3 standard deviations above average? They are freaking tall.
Yeah, that's a
Mucho huge.
very small.
Or we could be 3 standard deviations below average, and we would get
Kim.
Kim. A cute little Kim Brandley. There it is. Okay, so within 3 SDs, you should have 99.7% of your data. So this little data set that we just used for this example, it's hard to see because this data set has approximately 5 data points. It's not very interesting. But what did we decide the standard deviation was for this data set? We decided that the SD was 6, correct? Okay, look up here at our actual data set. How far is 6 below? 6 below 12 would be 6, right? So 1 standard deviation is going to be at 6. 1 standard deviation below average is at 6, right? If I say it's 1 SD below, then it's 6 tardies less than average. Okay, so 1 SD above would be where? At 18. Okay, so 18 tardies represents 1 standard deviation above average. Good? Okay, how many points are in this data set? Okay, there's 5 of them. 3 of them fit within 1 standard deviation. 3 out of 5, that's 60%. Okay, in a tiny data set, it'll be something closer to that. In a normal size data set, a normal size data set usually has anywhere between 15 and multiple thousands of data points in it. So the bigger you get, the closer it will be to this number, but you'll get about, like I said, 68% in there. Okay, where is 2 SDs below average? Just curious. 0. That's a great goal to shoot for, just so you guys all know. 0.
So unreasonable.
Okay, what's 2 standard deviations above average? Good.
Wow.
That, my friends, that is a world record. You were tardy to every single class, including all 4 days of early morning seminary this week. No,
Yep.
no,
Break the world record.
no.
Get our name in the
No.
Guinness Books.
Good? So for us, again, teeny tiny data set. So look at this one more time. Look at these numbers for me. Do you see this right here?
Yep.
What is 95% of 5?
Not a nice.
Does that leave any points out? Somebody do 0.95 times 5 for me on a calculator. 95% of 5 data points, which would be rounded up to 5. So all 5 of our data points happen to be within 2 standard deviations, again, because it's such a tiny data set. Okay, if it was a slightly larger data set, like maybe all the kids here at Payson High, instead of just these 5 people, then we would see a few numbers, 5% of the numbers would be outside of 2 standard deviations. So below 0 or above 24. Okay, so this tardies example doesn't really work in this situation. You can't really have less than 0. You can't really have more than 24 this week. So yeah. But otherwise, in a data set that had more options, we would be able to go outside of that 95%. And then we would never, ever, ever be shocked if all the data is within 3 standard deviations. Because the only time it won't be is if there are a ton of data points and you just get 1 or 2 stragglers really low or really high. Okay? Good? Does that seem easy enough? Okay. All right.